Hello, and welcome to our webinar, Net Zero Engineering Solutions in the Built Environment, Calculating Embodied Carbon in MEP Systems. This is the third and final webinar in our series provided by the DAR Group for the Major Projects Association. I'd like to take this opportunity to say that the videos of the previous webinars, Transitioning UK City Centres Towards Sustainability in a Post-Pandemic World, and Beyond Zero, How to Achieve Sustainability in the Built Environment, can be viewed on the MPA website or the Pine Media Library platform. My name is Scott Smith, and I'm Head of Sustainability for DAR UK. I will be facilitating this webinar and will be helping in the Q&A session after the presentation. So please feel free to ask any questions during the talk through the chat function, and we will try to answer them at the end of the presentation. So now I would like to introduce the speaker of today's event. Our presenter, Nathan Millar, is the Sustainability Principal at Elementa Consulting in London. Elementa Consulting, which is a member of the Integral Group of North America and Australia, is an interactive global network of design professionals collaborating under a single deep green engineering. They provide a full range of building system design and energy analysis services with a staff widely regarded as innovative leaders in their fields. Elementa Integral spans the globe with offices across the United Kingdom, Europe, North America, and Australia. Nathan is a sustainability and environmental design with over 15 years experience working in the built environment. He has worked in both the public and private sector, developing and delivering sustainable strategies, environmental design guidance, and an interface between architects and engineers. He currently leads Elementa's sustainability and environmental design team in the UK and Europe. As you can see, Nathan is the key principal for sustainability in Elementa, and he brings a wealth of knowledge to the topic of this webinar. Therefore, let me hand over to Nathan. Nathan, over to you.
Thanks a lot, Scott. Good afternoon, everybody. Just by way of introduction, just to give you a little bit more information around the company. As Scott mentioned, I'm a principal at Elementa Consulting. We're part of a global network of offices. At the moment, we have 21 offices globally. We're around just over 700 members of staff, of which we have just around 75, 76 within our two offices within the UK, one in London and Oxford. What this network, and it is a true network of offices, allows us to do is really stretch our knowledge and our understanding and really bring knowledge transfer across our offices on a global scale. And through the presentation, we'll be able to see how that articulates itself, both in the work that we do and also the studies that we're undertaking and the driving change within the industry on different numbers, different topics and different themes. So Elementa, or Integral Group as we're known globally, we're a purpose-driven company. We are deep green engineers focused on the approach and how we can deliver zero carbon developments and or retrofits, and really wanting to drive change and realize a regenerative future for us, both as a company, but also as an industry as well, putting in place the strategies and the opportunities with our clients that we can wherever possible. So today, this is the agenda that we're just going to run through. It's going to be somewhere between 30 and 40 minutes. I always like to be optimistic and say 30 minutes here, but sometimes, I can dwell on things. But what we're going to look at is some of the definitions and context around zero carbon and embodied carbon. Also, some of the key interfaces that we've identified between embodied carbon and MEP equipment and systems. Some key takeaways from how we could go about reducing embodied carbon within MEP systems, and then also a overview and summary of the recently launched CIBSE TM65, which looks directly at calculation methodology and approach for embodied carbon within MEP systems. So I'm just going to take the opportunity just to have a little introduction, just to frame the challenge, to frame where we find ourselves as an industry and as practitioners within at the moment. So what we know is we've got a challenge at the moment, which is to deliver as many well, as many of the buildings as we can by 2030 need to be delivered to net zero or zero carbon standards. But we know that that's only going to occupy a very small amount of the overall built environment, that context that we're dealing with. And we know that, you know, by 2050, according to as part of the UK timelines, we're going to have, you know, almost 99% of building stock needs to be aligned to that pathway. So this is a really big challenge and something that we need to focus on. We know that there is no planet B. This is our only option. This is what we're here with, and this is what we've got to deal with. And through, you know, Paris COP21 and now this year's COP26, with which Elementa or Integral Group and DAR Group, with collaboration with Scott, we're really working to be able to maximize the opportunities that COP26 is going to present to really articulate and push what we need to within this sector. So we know this is an imperative. We know that it's something that we need to improve upon and achieve. Ooh, sorry, I think my slides are stuck. And we know that action is required today. So we've got that timeline that we've got. This is the pathway to net zero, which was devised by or developed through Leti. Leti that we'll come on to a little bit later. But this identifies that 100% of all new buildings by 2030 need to be zero carbon in order for us to achieve the targets within those timelines that are set both by government, but also through the COP21 and the 1.5 degree increase. So we're seeing, that's just a little bit of a background, and just to frame a little bit of context around what we talk about at the moment. We know that in the industry we talk an awful lot around operational net zero. There may be a little bit more understanding about that sector and how that has been the real drive and the push over the recent years. So this is the definition from the World Green Building Council about advancing net zero and what their definition of a net zero building is. And that's looking at operational energy and carbon within the building's operation. And from that, we know what we need to do in terms of delivering net zero. We know that there's a limited budget in terms of renewables that can be generated within the UK, and then we know from that what the operational targets of different building typologies need to be, whether they're new or whether they're going to be retrofit, what budget and where that fits within the overall story, and the overall ability of developments to work towards realizing net zero carbon. So the main metric that we use, that I'm sure a lot of you are familiar with or are starting to be hearing about, is around an energy use intensity. And what the benefit is of this is, like I said, it allows us to set a budget for different building types and different building functions. And through some of the Leti guidance and publications that you may have seen, such as the emergency design guidelines, those budgets, an EEY target has been set for residential buildings. I must confess this is related to new, for residential buildings, for education buildings, for commercial buildings. And then, so once you design your operational energy performance within that contextual, within that budget, then you can have a semblance of confidence that your development is going to be on that timeline and on that projection timeline to net zero that we need to achieve for all of our sakes. So in order to achieve operational net zero, there's a lot of the strategies that everybody's really familiar with, and I just wanted to touch upon this initial conversation to then expand and move on to looking at other aspects. So we know that we need to reduce the amount of energy that a building uses and consumes, and the primary way that we look to do that is through passive design responses, making sure that our window to wall ratios are suitable and effective, making sure that the fabric performance is appropriate and is going to be sufficiently high performance. So you're having conversations, I'm sure, a lot of within a lot of your projects on the relative benefits of triple glazing, some of the challenges that we may be facing in terms of design around those really good, well-performing envelopes. Providing heat in a low and zero carbon way. I'm sure everybody's familiar with the decarbonisation approaches the non-combustion approaches now that are being promoted and prioritised and seen within the vast majority, if not all, of the developments that we're currently working on, whether that be related to a heat pump solution or a direct electric solution, but making sure that the right solution is identified and implemented for each individual project to maximize both the energy performance, but the ultimate carbon reductions or the carbon emissions that are going to be recognized from that operation of that building or that development. Demand response. So how can we use the building in an intelligent way to make sure that our demands are reduced as much as possible? We're seeing a lot of development around battery storage and the applicability of battery storage to different projects and how that can happen and function. We've got the contribution of renewables, maximizing those both on site, but also looking for opportunities off-site, where maybe on a portfolio scale or an estate scale, where that needs to be just because the physical land use and physical land area isn't available within a red line for any one development. And then most importantly, data disclosure. And why this is the most important is we need to, as an industry, learn what works and, more importantly, learn what doesn't work. And only through that can we as a built environment professionals and as a collective or a collaborative really start to make sure that all of the most appropriate strategies and design guides and standards that we do are known and are applied wherever we can and wherever possible. So what we're seeing is obviously the real push on the fabric first approach. So how we can develop a passive design guide. So this is, thinking about whether a passive house approach could be used, and we're not saying full certification, but just thinking about those smart moves and some of those guidance that is already seen in the industry and practically delivered that can really be used to carry forward to other projects and future projects. As you mentioned, demand response. And this is a real area that's currently growing, and the intelligence around this, the application of smart grids, how we can use electrical vehicle charging in the future. We know we're going to have this potential huge battery supply that we can use. How can we make that intelligent, and how can we make that profile to make sure that there's a two-way connection to allow demand and to allow power to go to buildings or to cities at a scale where that demand is needed and it can be reduced. So around that conversation about operational energy and the implications around carbon emissions, this is quite a more mature conversation, a more mature known. But we know through the work that we've been doing, and I'm sure that it's being seen at the moment, we need to have a life cycle approach. We need to think beyond, or a high life approach. We need to think beyond potentially what operational carbon impacts are. We need to think about this as a life cycle assessment. Ultimately, we've got a number of impacts that are going to happen from the built environment, whether from climate change to acidification, eutrophication, to just water consumption through the design, the construction, the operation, and ultimately the disassembly of any building or any development. And these are all key criteria that we need to think about, and hopefully some of these conversations are becoming more prevalent in the work that we're all doing. So in the building context, we look at a life cycle approach reflecting a variety of different modules, and this is based on the life cycle approach for the EN standard, whereby we've got stage A, which is looking at the products itself and the construction process. You've got life cycle stage B, which is looking at the building in use, both including maintenance and repair of materials, but also the operation of the building, where all of the hard work and the effort that we do and we continue to do around the development of energy efficient solutions comes into practice and comes into play. And then we've got module C and D. C, looking at the end of life. How is the building going to be deconstructed? What opportunities are there for any waste processing? And then within D, thinking about it as a circular approach. What can be reused, what can be recovered, and what can be recycled? So as we look at a whole building context, we are having these conversations around adaptability, around modularization, MMC. All of these different topics relate very much to that life cycle, because there's benefits that are going to be realized within that. Within the building context, I'm sure there's a lot of conversations where you've heard around what an EPD and what EPDs include. EPDs are focused purely on the product itself, and so some of the full modules would not be considered within an EPD. While EPDs are something that we endorse and we really encourage everybody to identify and apply as part of their projects, it's just important to see what's included and what's not included, just so you can have an appreciation and a mature conversation around that issue. So ultimately, within the whole of that life cycle, whether that be around climate change or eutrophication or acidification, ultimately we're all coming back to carbon emissions. And so the ultimate metric that we have around when we talk around life cycle and assessment analysis is basically a CO2 equivalent, which is what that E means. So that's how we communicate, and we bring all of those different issues together and allow us to talk in a and discuss these topics in a standardized way, where everybody's clear very much on what's being spoken about and what's included and what's not. So yeah, this is ultimately the evaluation of the global warming potential of any building or any building asset, any building element, and so this is the piece that you'll be hearing about as we go through this presentation, but also when you're looking at this topic on developments and projects of your own. So what's included in embodied carbon? We've spoken about operational. That's known. That's kind of heating, power within a building. We know what that is. But the embodied carbon aspect is something which is now becoming more familiar. So when we're talking about embodied carbon, we're talking about carbon emissions associated with the products, the making, the construction, and the end of life of that asset. So coming back to our life cycle modules, on the left hand side, that they've picked out what different modules are captured within that initial embodied carbon assessment. And we talk very much around upfront embodied carbon. So the materiality of the building. Is it a structure, the timber structure? Is it concrete? Is it steel? Is there another, have we got aluminium framing? We've got timber framing. All of these different aspects which come together to make up, as you can see on that graph, what is perceived to be the bulk of development's embodied carbon. But as we know, within operational carbon, we've obviously got the emissions associated with the use of energy and the use of water, which can also go to make up that contribution to that whole life carbon of a building or a development. And then bringing that together is the only way that we can really get that appreciation of that whole life carbon approach. So we've got the embodied carbon of the materials that are going to go into the building. We know what the operational carbon is through our energy modeling and our system selections. And we can start to have a conversation around the emissions and removals that would be associated with our circular approach. So where we talk about modularization, designing for deconstruction, All of these different topics, that's where those issues see their the benefit of those issues is seen. And so when you combine that together, you end up with that whole life approach, that whole life carbon aspect of a development, looking primarily through RICS and the EN standard. That's 60. That's generally a 60-year life cycle. The life cycle could be determined by your client. It could be longer. But that's within the industry standard. And so we're picking out all of these different aspects, looking, like I said, at the embodied carbon of the building. So primarily looking traditionally at the structure, operation, how much energy is it using and what's associated with those carbon emissions, and you'll see some additional modules within the building operation looking at replacement and recycling and maintenance, those impacts, and then ultimately at the end, the reuse and recovery. So where does that balance sit? What we come back to though is we're talking about carbon. So this is a temperature plot showing the amount of carbon and global resultant warming that we're seeing, just done as a color palette, as opposed to just having our normal graph, which shows a projection and an increase, just to give a real graphic representation of the bind that we see ourselves in at the moment. What we found as a company, as a practice, was, and something we were very keen to explore, was we know where the conversation is around embodied carbon of structure and main build, those primary building elements, whether that be substructure, superstructure, envelope. But where does it fit in? Well, how does MEP fit into this conversation? There's an awful lot of different aspects that, as part of those embodied carbon studies and those hard work that we do around embodied carbon on those primary principal elements, there's quite a bit that's missed within MEP. We've got lighting, you've got your HVAC, you've got your lifts, any acoustics performance, you've got your BMS systems, and all of these need to, if we're going to have this, set these targets and look to really push and deliver them, we need to know about this this whole other sector, or this whole other proportion and element of a building, to educate ourselves and make sure that we know what our decisions are and how they're going to be impactful. And it's becoming more and more relevant. Obviously, if we look at MEP systems, we've always spoken traditionally around the operational, how energy efficient they are, what they're, how much carbon they produce. But in the UK, obviously, we know that we've got a future decarbonisation of the grid. We know that we're transitioning from a combustion-led grid to one that, which hopefully, if we continue on trajectory, will continue to be primarily based upon renewables. So the overall contribution of carbon within MEP solutions is moving from traditional operational emissions, more to, well, what's the embodied carbon of the stuff that is making up our equipment? Obviously, we've touched upon zero operational carbon buildings. I mean, just to show, or to give an example of, or a demonstration of where we've come from, Elementor, as part of Integral Group, we've been involved in the design of more than 100 net zero energy buildings. So we know what needs to be done to deliver on operational carbon buildings. And so we felt it was incumbent upon us to make sure that we completed our knowledge and shared that knowledge and understanding, and drive hopefully drive the industry to create that shared knowledge and appreciation of these different topics that we need to think about. So just in terms of having thoughts around, well, what's the general quantities of building services? There's not much. You may just think, oh, it's some a fan coil unit here, or some conduit there, maybe a little of some Ethernet for data distribution. But if we look at a typical 2,000 square meter building, there's a lot of stuff in there. There's a lot of equipment. There's a lot of MEP going on, and that actually, roughly, from a few studies that we've done on a apples for apples, that roughly equates to 25 tons within a 2,000 square meter building, normal building, which has, which is equivalent to a fin whale, which I'm going to use for just an extrapolation and an example, very random, but that's what the team decided on. That was where the good correlation was. So when we think about that at scale, 25 tons for one building, that doesn't really sound very much, but when we scale it, so for example, we've got the reference here from New York, where we know New York City is 785 kilometers square of land. Rough estimation, 70% of that is covered with buildings. Then all of a sudden, all of that embodied carbon that traditionally we've never really thought about, which is going in our MEP equipment, has huge significance. And the scale is something that we really need to think about and capture. Then this is related to buildings itself. We've also got horizontal systems connecting all of these buildings together, water, power, heating, cooling networks. The amount of stuff that goes into delivering MEP equipment and systems and supporting buildings is huge. And so we really need to understand exactly what the embodied carbon is of our decisions that we're going to be making. So the primary materials that we see within building services are steel, copper, aluminium, cast iron, rare earth materials as well, and an awful lot of plastics. So there's the kind of stuff within these systems which have relatively high embodied carbon implications when compared against other materials that could be used or that have a lower embodied carbon but can't perform the same function within the MEP world. We know that in comparison to a building, the building services within that building, they have a much higher replacement rate. So the maintenance and the replacement requirements are paramount to those decision-making processes and have a big implication if we think about, a fan coil unit, for example. So very standard, book standard system solution to provide heating and cooling within a space that we see. But there's a lot of maintenance that's required in terms of replacement of filtration, potentially replacement of coil or anything like that during that unit's overall lifetime. And so those considerations we also need to take into account. And it was very much within this appreciation or burgeoning understanding of, once we started, oh wow, this is significant and something we really need to find out more. Elementor, we really, hopefully picked up the mantle and is trying to identify and provide information to the industry. So that started in 2019, where we worked with CIBSE around embodied carbon of heating systems. We then started looking at how MEP fits into a whole life carbon approach of building case studies, and I'll come on to a couple of those shortly. We've worked with Letty around the embodied carbon primer as part of that collaboration, industry-wide collaboration. We've produced refrigerant best practice, and we'll come on to why that's important as well. Recently, although earlier this year, we published CIBSE TM65 as well, which looked at a calculation methodology, and we'll have a little summary of that. So over time, we've really been picking up the momentum that we feel, and understanding that we feel is needed, both for ourselves as engineers, so we can make the right decision, but also to share knowledge within the industry. And hopefully, as I said, these conversations will become more prevalent and more mature as we move forward. So let's just have a look at some key findings around what impact MEP systems have on embodied carbon within a building. So they're just going to run through a couple of examples. So, this is embodied carbon of MEP systems within an office environment. And within a new build office, we've seen that MEP could account for up to 50% of the embodied carbon impact of a building, and that will be dependent on the systems that are being provided or the approach that's being suggested. When we've done some looking at within MEP itself, where's the split? We know, or we've identified that really between the materiality itself of public health to electrical to HVAC solutions, there's a pretty equal split. One of the key parameters that we've identified or we found was on the heating and cooling side was the impact of refrigerant leakage, and that's really important because now, within the advent of non-combustion solutions, within buildings being the primary approach, we're having conversations. We're looking at the design of air source heat pump, potential VR, using VRF systems, ground source heat pumps. So anything where there's a refrigerant involved, we really need to know exactly what that is, what the charge is, what the leakage rate is, and make sure that we're making all of those good decisions with understanding and cognizance of what the potential for the embodied carbon is. And this is one of the key topics that we continue to research and continue to develop internally, both within the UK but also globally. Within another study that we looked at was what would the impact be if we looked at it within a decision matrix combined with structural solutions. So we compared a typical office building which had a steel structure with a VRF and heat pump system to that of a building which has a precast concrete which could allow thermal mass and also use a radiant system, which has, in terms of energy performance, we would like to think in most cases that will provide a more efficient energy solution. And does that stack up in terms of looking at the embodied carbon? And it was really interesting to see that the contribution of the mechanical equipment within a conventional steel structured building when compared to a precast concrete building, was really significant. And so being able to have these conversations around these different options that we're proposing, or these different solutions that could be there, becoming really interesting. There's more issues to discuss, there's more knowledge to have, and there's more understanding to be able to glean when you look at the holistic approach to carbon within the building design. And then, as I said, with that option that we, or that comparison option that we looked at with the VRF system to a radiant system, the refrigerant impact was really significant. And the more studies that we do on these, this is really one of the key issues and the parameters that we're seeing coming up more and more. As I said, we've developed, or we've started to provide information on this. We've provided a refrigerant best practice guidance, which is available from our website, which articulates and identifies a little bit more around those different impacts on refrigerant. So if anybody's interested, we have made that information available. We have identified, some of those selection parameters we think are sensible, and we have have a comparison of different systems approaches, whether that be centralized or distributed systems, such as a VRF system, which we were just speaking or using, or individual DX system, or individual heat pump systems. And again, that's just taking our lessons and our learnings and being able to provide them to other people. So that's kind of thinking about a new build. When we look at office fit out or refurbishments, just because there's the proportion of stuff and the technical term stuff that goes into those kind of projects, MEP contributes, a lot more, because the existing structures in place, a lot of the finishes, could be those architectural finishes could be retained as part of that process. And so the impact of MEP systems is potentially much more significant. So when we go back to the conversation we had right at the beginning, setting the scene, and we say, right, new build, we know that that's going to be 1% of the stock. We know we've got almost 90, probably 99% of the stock existing buildings that we need to bring. We need to, as those are refurbished, retrofitted, we need to make sure that these topics and these conversations around MEP equipment and embodied carbon form part of that conversation, just because the contribution is so much more. So from one of the outcomes of the study that we found was, having the conversation with the client in this case about, whether it was appropriate to go back to a Cat A, or whether there was, is there more of a median intervention that we could have that reduces the overall potential impact? How come, providing those suite of options that means that the equipment selections are appropriate, and they're designed to deliver what's needed within that space, not be oversized, and the equipment is appropriately delivered. Sorry, just wait for the slide to click through. Ooh, one too many. And what that also allows us to is identify those hotspots where we really need to focus, whether that's on the emission of heating or the emitting of heating and cooling, distribution, air distribution, and controls. And we can see where those, as we do more of these studies, we can see the lessons of where we need to focus and concentrate on the different packages and those different functions that make up MEP equipment. So what are the key takeaways for how we can reduce embodied carbon in MEP design? So ultimately less. Just, weight is a huge, if we can reduce the overall weight of MEP equipment within a building, then we know that there's going to be less stuff, less material in it. The embodied carbon is going to be reduced. Really super simple. Think in terms of circularity, specify products and components which we can demount, we can reuse, that could be disassembled. And make sure we do the simple things like providing simple access for inspection, maintenance, and replacement, making sure that things aren't too complicated to get to. Very simple. One of the things which we're seeing more and more now is when we talk to vendors about the specification of materials, or sorry, the specification of systems that we're doing, and we're having these conversations, they're becoming much more used to being asked the question and having the answers available, and if not, willing to work and collaborate to try and identify what that answer is. Mitigate refrigerant leakage wherever possible, through this, and specify refrigerants with low global warming potentials. And try and ensure that all refrigerant is 100% recoverable, so it doesn't disappear. Specify low embodied carbon materials. This is just a plot showing, a like-for-like comparison. And the big one is obviously aluminium, but there's the embodied carbon that's impacted by the selection of that material, and also brass and copper. These are things that we see in terms of materials quite a lot within MEP equipment. So really need to think about their use. And then as we said, this is not a journey that we've been going on our own. It's very much a collaborative journey with the industry, through whether that's through our convening of LETI and everything that's gone on to produce as that great collaborative effort across the whole of the built environment. Over 1,000 built environment professionals now involved in the development of definitions, standards, guidelines, and targets. But one of the things that we've worked with over the last year directly with CIBSE is the development of TM65, which, while we had a methodology of how to calculate embodied carbon for building elements and products, as I said, MEP equipment was a really grey area which no one really spoke about. So earlier this year, we wrote and designed, designed and wrote the TM65, and which looked and focused on the embodied carbon, mainly because there's a complete lack of EPDs within the MEP world. The main aim was to be able for us to have a proper comparison, allowing EPDs to be cross-referenced and referable across projects, but also across equipment selections, because some of them were not set out in that way. So again, the aim and the scope of this CIBSE TM65 is to capture as many of those relevant modules that we have. So in a product level, this is going back to the EPDs, so looking at the module A elements, a portion of the module B elements, not consideration of operational, because that has no bearing on the materiality and the embodied carbon of the equipment itself. We capture operational carbon on the use of that equipment, but also how the MEP equipment can be used as a part of the end of life. So we've identified that process. So just in summary, what information do you need from your manufacturer, providing pro formas for them to complete, what calculation approaches can be done, and then what reporting format should be used. Again, just so there's this consistency within the industry to talk around the topic. The way that it's been set out is hopefully a very simple step-by-step guidance that people can pick up and they can use. And then we've allowed for different implementation of calculations, whether from a relatively basic calculation to get an understanding and a mid-level calculate right to a full EPD. And we're very much targeted on how to generate EPDs for MEP equipment and products. Within the appendix, there's clear guidance and instructions on how to undertake basic calculations, what modules you're looking at within the life cycle approach, and also mid-level calculations and full EPDs. And again, this is just to create a level playing field within the industry, and allow us to have a like-for-like discussion across projects, across vendors, and products. And then as some examples are also given in terms of what the kind of differences of information that can be provided within that basic calculation to that mid-level calculation. So what I would say is, if you haven't seen this or haven't got a copy and you're interested in finding out more about embodied carbon within MEP equipment, please go and have a look at the CIBSE TM65. It's a really, what I think is a really useful and informative tool and document that was produced in collaboration with CIBSE, with quite a few people at Elementa, but primarily Louise and Clara. So that's hopefully just about to time, Scott. So thanks everybody. And I think if there's any questions that people have, we'd be very happy to field those.
Yeah, thank you very much, Nathan. If you can stop sharing. Oh, brilliant. I don't have to do it. Yeah, there's a few questions. One is, what manufacturer uptake did you have so far?
Interesting. So at the beginning, it was relatively tricky to get the information from manufacturers, and that was on a couple of points. One, there's obviously the IP issue that they could be worried about, but also the fact that they just never looked. It had never been part of the conversation before. So if we look at that timeline from when we started looking at this in anger in like 2019 to where we are today, it was very difficult in 2019. It's becoming more simple or more understandable within the industry now, but obviously there's still some way to go, and we're always looking for working with manufacturers who want to find out a little bit more and are keen to learn about their products.
Yeah, I would assume that you know, the newness of all of this is kind of a shock to the supply chain and, you know, the manufacturing of MEP equipment. But
yeah,
you know,
I mean, one of the pieces of work that we're doing at the moment with the industry and manufacturers is developing a bit of a research insight paper into the relationship between our work and manufacturers as well. So yeah, like I say, historically it was not great, but I think that was like you say, an education, but now it's getting much better.
and obviously, have you garnered a lot of, you know, positive response from manufacturers now?
Yeah, I think so. And I think because obviously we don't talk to all of them. The ones that we do talk to, it's generally positive, you know, and they're, I think they just want to know exactly the same as we do. It's important to them. They see what the future holds and they see the direction of travel that we're going as the industry. And if they don't necessarily know or are unwilling to learn, then it's going to be a challenge for them in going forward.
Yeah, I would assume to be able to kind of have a, you know, nice badge or a green badge for your product, you know, is probably a good selling point for some manufacturers.
Yeah, absolutely.
Okay, has there been any global uptake for this?
So at the moment, the TM65 is just related to the UK market and the UK products. But we are developing at the moment, an addendum which can then be used to adapt to other regions. So, for example, we're working at the moment through our collaborating with our Australian offices to apply the CIBSI's TM65 approach to that market and the specifics of what they need and what information is available there. We're also working in North America with ASHRAE and looking to almost set up a consistent approach across different jurisdictions. So yeah, for US and Canada, we're doing a similar thing as we're doing in Australia.
Oh, brilliant. Okay. What and who are the biggest constraints on a typical project for adopting this type of, you know, embodied services methodology, in your opinion?
I think, I mean, the biggest constraint is just knowledge and availability of information. We haven't, in our experience, we've not to date really received pushback on, oh, I don't want to know this. I don't, you know, this isn't of interest to me. Where the clients we work with are interested to know. The contractors that we work with see, you know, what their implications are, that is going to be that those decisions, the decisions that they make could have. So I think just the biggest challenge is just knowledge. And in terms of the biggest challenge in identifying or working through the calculation of what the embodied carbon impact, it generally is return time of information exchange from supplier or equipment supplier to whoever's asking that question, whether that's us or another building services engineer.
Okay. Would you also think that as a designer or, you know, kind of somebody who specifies equipment, that, you know, would that be a constraint to, you know, picking one service strategy over another based on embodied carbon? Or
I think the biggest conversation we have at the moment is around refrigerants, particularly with like the non-combustion approach that we're looking that is coming in, and like the electrification of systems. It is, when we look at it in a holistic fashion, and that could be, you know, overall energy reductions, potential capex, opex with the client, which is obviously going to be primary for them. And then, you know, the embodied carbon of the system selection is also starting to form some of that conversation is probably not got the, at the moment, got the weighting that you would expect from a CapEx, OpEx kind of decision. But it is something that we can engage the client with to demonstrate on why we think one solution may be better in the long term in terms of carbon than another. But at the moment, that's very much based around refrigerant use and the impact from different system selections.
Okay. One of the hardest aspects of embodied carbon calculation of a services design is where you draw the line in terms of the scope of the calculation. Can you shed some light on this, and what do you tend to exclude in the assessment?
Yeah, so that very valid question, and that's basically why the TM65 was developed and was written. So while I'm not going to shirk the answer, I would just say go in there and read that document. That identifies exactly what fits in, what should be included and what shouldn't be included, both for an engineer, but also for the manufacturer or the product supplier as well. When we come back to, because the key, I suppose the key slide for that one is making sure you get an apples for apples comparison, and you're not looking at apples and apples and oranges that are going to be completely disbalanced. You want that fix to make sure that if I'm looking at a particular luminaire, for example, and embodied carbon is of interest to me, I want to make sure that when I'm looking at another one, it reflects the EPD that's associated with that product marries up. And in terms of what's included and what's excluded, all of the modules that should be included within the development of the EPD for all of those products is clearly articulated in the calculation methodology of TM65.
On that then, has the tool been developed to simplify the TM65 approach?
So that is part of the ongoing work that we're doing with CIBSE at the moment, and that's being finalized. That should be, we're hopeful that training for that or release of that will be Q3, back end of Q3 this year, so September, October time.
So there will be a kind of a
that's
one-click LCA is kind of a simplified.
Yeah, I wouldn't. It's not. I don't think it's not going to be as complicated as that. But yes,
okay.
Similar. Right. Similar one point destination where you can go and can use that tool to identify what the embodied carbon of different products and equipment is.
Since this, embodied carbon of MEP systems is relatively new, I would assume that there's not a wealth of data that can be analyzed to look at trends of what's going on. Obviously, you've presented in your presentation, some comparisons and stuff. Is there any, overview of good embodied services targets that we should be going for?
We not in terms of setting a kilograms of CO2 equivalent. We're very much in, we don't really know what good looks like still, so it's still very much a finding out process, just to educate ourselves. I think ultimately in the future we could think about setting targets, but at the moment there's no kind of fixed targets or anything that's been implemented. We're very much about learning what it is, and then as an industry coming together and pushing forward with what we think good should be and is.
And on that, obviously, is there going to be a body, or are you in discussion with CIBSE or another body to gather this information, or is it you do a project, you calculate the services embodied carbon and that's it, or?
So yeah, there is there's no real plan to have like a central database. I think the ultimate product is the EPD, because that's going to be completely open to anybody. They could be housed and homed by CIBSE. There's no reason why that couldn't be the case. but at the moment, yeah, there's no kind of like central point and reference that's planned. But that's not to say that it won't happen.
Okay, to what extent do techniques like offsite manufacture facilitate reducing MEP, embodied carbon?
Yeah, I mean, very similar transfer than you would expect from, you know, some of those other modular offsite construction processes that we see generally in buildings. The biggest benefit is obviously reducing material waste wherever we can, and just, you know, focus on material use. So where there's a system or solution that is appropriate for offsite manufacturer to bring on site, then yeah, the similar benefits are seen. I think that probably the difference with MEP is that we tend to deal with whole products that's like bought on site, whether that's air source heat pump or some electrical distribution boards. They tend to come as a product. One of the things that is slightly tangential, but is thinking about the amount of material that's used. So, for example, if you're thinking about, you know, power distribution, there's always cases that we see, you know, where, you know, you just see maybe a pile of cabling like hooked up somewhere, or making sure that those things don't tend to happen.
Okay. You mentioned that you have a wealth of data on your Elementa website. Is that?
Yeah, so there's a lot of I say a lot. There's design or guidance documents, and also studies that we've done that are available on the Elementor and Integral website. So the refrigerant best practice guide, there's a deep dive into one of those, the comparative study between a steel VRF and concrete radiant building. There's a deep dive study and document all about that study and the building that's based on. And yeah, we're always updating the website with regards to presentations such as this around, you know, different topics within the embodied carbon of MEP and the work that's being done.
So it's just a kind of a quick Google search on it for Elementa Consulting, and you should be able to get that information.
Yeah, you should have access to that information. If not, happy to share that with anybody. So, you know, feel free to reach out.
And on a related one, there's a question: are the CIBSE resources that you mentioned, TM65, open access, or do you need to be a member? I actually know the answer to this.
Yeah, you need to be a member, but
it is. You can buy it, purchase it for £20.
You can purchase it as a non-member. If you're a member, you can get it obviously for free. But yeah, as a non-member, you need to purchase it.
Yeah. Okay. Thank you very much, Nathan. That was a really informative, really interesting presentation. I'm going to introduce Eleanor Bergquist, the MPA Events Manager. She will then kind of explain or tell everybody about the upcoming events. Eleanor?
Thank you, Scott. So I just wanted to say thank you briefly to Scott and Nathan for today, and particularly to Scott as well, who's chaired our last 3 seminars in collaboration with DAR Group. This is our last seminar in the latest series with DAR Group, but we do hope to announce another series with another one of our member organisations very soon. You can see on screen some of our upcoming events, the next of which is our Quest for Net Zero seminar tomorrow. There is still time to register for that one on our website if you'd like to attend. And obviously there's a few of our other upcoming events on screen now as well. And then the last thing to say is it's really good if you can complete feedback for our events. We do take it seriously when we're planning for our future events. There's a code there for you to complete a short feedback survey on mentimeter.com. You just need to go to www.menti.com and use the code 86475453, and we'll circulate that in an email to you after the event. Thank you.